So hey guys, welcome back to my YouTube channel. So for this video, I will doing a summary of chapter 5. So from chapter 5, Ethernet. So Ethernet is now the predominant LAN technology in the world. So Ethernet operates in the data link layer and the physical layer. So the Ethernet operates the data link and the physical layer. So data link layer and physical layer, if you watch this watch my video previously, so it what do you call this, it said that the meaning of the data link layer and physical layer, and the Internet Protocol standards define many aspects of network communication, including frame formats, frame size, timing, and encoding. So and because Ethernet is comprised of standard at this lower layer, it may be understood in reference to the OSI model. So the OSI model separates the link layer functionalities of addressing, framing, and accessing the media. So let's proceed for the next. So we will not we will skip this because we will discuss only the important. So we have the Ethernet encapsulation. So Ethernet operates the data link layer and the physical layer. So as you can see, we have data link and the physical. So 802.2 for the data link and the 8002.3. So Ethernet is defined by the link layer and the physical layer protocol. So let's do the figure 2. So the um, so LLC sublayer, the Ethernet LLC sublayer handles the communication between upper layer and the lower layer. So this LLC sublayer um, handles the communication between the um, lower layer and the upper layer. So typically between the networking software and device hardware, the LLC sublayer takes the network protocol data, which is typically the IPv4 packet. And then for the MAC sublayer, MAC constitute the lower sublayer of the data link layer. MAC is implemented by hardware. So typically computer and NIC, the specifics are listed in the IEEE 802.3 standards. So figure 2 lists a common IEE is Ethernet standards. So here's the common IEE Ethernet standards. So proceed. So we have a sublayer. So for the sublayer is we have two primary responsibilities. We have data encapsulation and media access control. So for the data encapsulation, we have frame delimiting, addressing, and error detection. So for the media access control, we have a control of frame placement on and off the media and the media recovery. So for the um, data encapsulation, so data encapsulation process include frame assembly before the transmission and frame disassembly upon reception of the frame. So frame delimiting, the frame process provides important delimiters that are used to identify group of bits. So for the keyword for the frame delimiting, it used to identify for group of bits. So for the addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. So for error detection, we have each frame contains a trailer used to detect an error transmission. For the term of error detection is detect any error in transmission. So for the media access control, so the second responsibilities of Mac sublayer is media access control. Media access control is responsible for placement of frames on the media and the removal of frame from the media. So let's proceed. So as you can see, we have a Ethernet evolution timeline. So since the creation of Ethernet in 1973, standards has evolved from specifying faster and more flexible version of technology. So this ability Ethernet to improve over time in one of the main reason it has become so popular. Early version of Ethernet were relatively slow at 10 Mbps. So in the so as you can see, we have a fast version. So we have early version, so it has a slow at 10 Mbps. So the latest version operates 10 gigabits per second and faster. So let's proceed. So we have a figure too. So, so we have a Ethernet frame fields. We have preamble, 7 bytes, destination MAC address, 6 bytes, source MAC address, 6 bytes also, and the Ethernet type, we have 2 byte data, 46 to 1500 bytes, and FCS for frame check sequence field, we have a 4 bytes, and then we will we will not answer this activity. So as you can see, we will skipping all the activity because it will what do you call this? It has a separate video for all activity in all chapter. So as you can see, we have a hexadecimal numbering, we have decimal, binary, and hexadecimal. So MAC address internet identity. So MAC address structure, um, value is a direct result of IEE enforcement rules for vendors to ensure global unique address. So it is a unique address for each Ethernet. So as you can see, the rule established by IEE require any vendor sells Ethernet devices to register with the IEE. So assign the vendor of 3 byte. So 24-bit code called the organization unique identifier. So we have ARP broadcast. So all device powered on at the same time. So ARP broadcast can flood the local media. So as a broadcast frame, an ARP request is received and processed by every device on local network. On typical business, this broadcast would probably have minimal impact on the internet so network rather performed. So however, if a large number of devices were to be powered up all the start accessing network so services at the same time, there could be more reduction in performance. So in this ARP broadcast, it is a typical business network. So um, If a large number of these devices were powered up or starting accessing network at the same time, it will be reduction for performance. So if the number of devices are all powered up, so the network services or perform will not it reduction in performance. So let's proceed. So ARP spoofing. So here's the I will send an ARP reply and pretend to be a default gateway. I need the MAC address so of the default gateway. Um, so for the term of MAC address, it also means a physical address. So in some cases, the use of ARP can lead to potential security risk known as ARP spoofing or ARP poisoning. This is a technique used by attacker to reply an ARP request for an IPv4. So as you can see, this is the ARP spoofing. So for the summary of Ethernet, so here's the summary. Ethernet is the most widely used LAN or local area network technology today. It is a family networking technologies that are defined in the IEEE 802.2 and 802.3 standards. So Ethernet standards define both the layer 2 protocol and the layer 1 technologies. So there are two styles of Ethernet framing, IEE Ethernet standards in the DICS Ethernet standard, which is known referred as Ethernet 2. So, so DICS Ethernet is referred to Ethernet 2. So it's I will not read all of this because for this chapter it focuses on the um, IEE 80.2 and 802.3 and the art spoofing and the data link and physical. So thank you for watching and